So first of all, we need to talk about our basic algebraic properties. And you have most of this on your sheet. The only things that you don't have are these pieces. So addition property of equality says that if we have two variables or two numbers that equal each other, a equals b, then that means that we can add the same number to both sides without impacting or changing our equation. Okay? We don't make it untrue, make it false. So we can add the same number to both sides. A plus c equals b plus c. And what that means in words is you can add the same number to both sides, and that's legal. Then we have the subtraction property of equality, and that says that when you have a equals b again, you can take a minus c, and that will be equal to b minus c. We can subtract the same number from both sides. Our third property is the multiplication property of equality, which means that if we have a equals b again, then we can multiply the same number c times both b and a, and our equation will still work. We can multiply both sides by the same number. And of course, you remember the division property of equality, and that says that if a is equal to b, then we can divide both a and b by the same number, c. And in words, it says you can divide both sides of an equation by the same number. Finally, we have the substitution property of equality. And it says that if a equals b, then a can be substituted for b anywhere in that equation or expression, or in any equation or expression. You can substitute like values. All right, everybody got these? Away we go. So we're going to be doing some proofs, and these proofs will involve solving and justifying every single step. And we do this with algebra because it's familiar and comfortable, and then we'll transfer that information or that knowledge off to geometry in just a bit. Okay, so we want to learn the process and the steps. Okay, sorry. Know the process and the steps, and then we can, once we've learned that, we can use that for geometry. Okay, so the very first step is always in a proof to write your given down. So we were given an equation. That equation is 2x minus 5 equals 13. So your first step is always to write down what you've been given. If you can't do anything else in a proof, I want to see at least that. Okay? Now, how would we solve this equation? Add 5 to both sides. So what I recommend you doing is you say, I'm adding. Okay, so remember that you added. So we add 5 to both sides. Make it a little bit bigger. And that's called our addition property of equality. Okay, so when we do that, what will we get? So 2x equals 18. Why does 2x equal 18? Because you added these guys, right? So our rule or our reason for this one is just that we simplified. Okay? Next step. Write this down, Jaden. Okay? Next step, we're going to do what? Divide. And what are we dividing by? 2. Since we divided both sides by 2, we haven't broken any rules or changed it other than its appearance. That's our division property of equality. Okay? And when we do that, what do we get? X equals 9. How did we get that? We simplified. Easy peasy. You just did a proof, an algebraic proof. This will be what your proof will look like, or one of your proofs will look like on your final. Okay, thank you. Yes, sir. You will just for today, okay, just so that you get used to that structure, and then we'll take it to the next step and talk about geometric proofs. Okay, so we want to start you somewhere comfortable and familiar. You know how to do these, right? And it's second nature. You've done so many of these kinds of problems before. So we start you with the algebraic, and then we'll actually teach you geometric proofs after that. Okay? The difference is that sometimes we'll be told that M is the midpoint of segment AB. And so we have to know, what does midpoint mean? Okay? That means that segment AM is congruent to segment MB, and so forth. So this will be comfortable and familiar. It'll be a bit of a stretch when we get to the geometric side of things, but the same structure. Okay, we have to give reasons for why we're doing each of these things. All right, so let's look at another example. Okay, before we do that, we want to talk about the distributive property. The distributive property says that if we have a number A that is being multiplied by a quantity B plus C, then it's going to be equal to A times B plus A times C. And if we have a number A that's being multiplied by the quantity B minus C, then A times B minus A times C is the result. And you know that. We multiply everything inside the parentheses by the number that was outside to clear the parentheses, and that's distributive. Write it down. Write it down. So I've given you a skeletal framework of this to help you so you don't have to do some mad writing all day long. And we know these things, right? We're just refreshing our memory on them. Okay? Because we want to understand how the property or the structure of a proof works, and then we'll take that to the next level with geometry. Okay? All right, so here we go. So now we're told that we are going to solve 2 times the quantity x plus 1 is equal to a negative 4 and justify each step. So what is the very first step of every proof? Given. We want to write the given down. So what were we given? Okay. All right, so Zach H., what's the first thing you're going to do then when you want to solve this equation? Simplify by, before you can do that, we have to right. So we want to distribute. So when we're saying we're distributing, okay, you can call it DIST, right? You want to abbreviate, that's fine. And we are distributing the 2 to everyone. So we'll have 2x plus 2 equals a negative 4. Okay. Hannah, what's our next step? Okay. Usually we would simplify, right? But we've already done that by multiplying everybody. So our next step will be subtract. So when we're taking away that 2 from both sides, and our book often shows it like this. They will say 2x plus 2 minus 2 equals negative 4 minus 2, because they write it in one line. But if you want to put the minus 2 beneath each one, that's okay, like we did this last example. Okay. And when we do that, what do we get on the left-hand side? Tyler. It cancels out. So we'll have a 2x, right, equals what? Negative 6. And that is simplify. Okay. We actually did the math there and simplified, not just saying what we were doing to each side, but we did that math. Or you can call it combined like terms. Okay, that also works. Okay, what's our next step then, Nathan? And so you're dividing. And we get negative 3. Okay, and if you want to put simplify there, you certainly can. Okay, easy enough? Okay, nothing too scary there, right? All right. This is the stuff that you don't use quite as much. Okay, so there are times when we want to, we'll use it more in geometric proofs, but there are times when you need to arrange your equation differently, or you need to add parentheses and so forth. Okay, so, or you want to show symmetry. Okay, transitive should look somewhat familiar to you as well. So our reflexive property says in real numbers A equals A. Reflexive is like a reflection in the mirror. You see yourself, right? So when A equals A, think of reflection, reflexive. Okay? Segment lengths-wise, that would say that the distance between A and B is equal to the distance between A and B. And with angle measures, that just says the measure of angle A will be equal to the measure of angle A. It's equal to itself. Okay, we'll need these for our proofs coming up, our geometric proofs. They seem too easy, too simple. Okay, symmetric then says if A equals B, then B equals A. We use that a lot in algebra without really realizing it, because we'll end up working something out and we'll have negative 1 equals x, but we like to have that x on the other side. So instead we'll say x equals negative 1. When we do that, we've used symmetric. Okay, the symmetric property says you can switch the signs of the equal sign. Okay, kind of like our converse that we were using in our conditional statements. Symmetric, I think of it as my face and my body is symmetric with respect to the top of my head to between my feet. And so theoretically you could switch sides. Okay? So symmetry is switching the sides. If the distance between A and B equals the distance between C and D, then we can switch the order and say the distance between C and D equals the distance between A and B. Okay, that's all it's saying from a segment length standpoint. And again, if we want to get it to the other side of the equation and the measure of angle A equals the measure of angle B, we can switch it and say the measure of angle B equals the measure of angle A. All right, and then finally, transitive looks kind of like what? What does that remind you of? Law of syllogism. That looks just like the law of syllogism. If P implies Q and Q implies R, we get rid of the redundancy and P implies R. It looks just like that. P implies Q, Q implies R. These guys are the same, so we can eliminate the redundancy and say P implies R. That was our law of syllogism. Looks very similar to transitive. Okay. All right. So in segment standpoint, from a segment standpoint, if the distance between A and B is equal to the distance between C and D, and the distance between C and D equals the distance between E and F, then we can eliminate the redundancy, get rid of the distance between C and D, and say simply the distance between A and B equals the distance between E and F. Okay? And then also same thing works with angles. Measure of angle A equals the measure of angle B, and measure of angle B equals measure of angle C. We can eliminate the whole redundancy of talking about B's and say the measure of angle A equals the measure of angle C. All right, looks like you're good with writing, so let's keep going. All right, so we want to name the property of equality that justifies each statement. So what says that if the measure of angle A is equal to the measure of angle B, then we can rewrite this to say the measure of angle B is the same as the measure of angle A. What have we done from here to here? Symmetric. So that's our symmetric property. And you can call it SYMM. Okay. We'll abbreviate, save ourselves some writing. What says if the distance between J and K plus the distance between K and L is equal to the distance between G and H plus the distance between K and L, then the distance between J and K is equal to the distance between G and H. Kind of looks like it could be a transitive, right? But that's got a if one thing, not, is it symmetric? We switch the size of the equal sign like we did here? I heard someone say it right from the very beginning. Okay, how is this changed? From here to here. Looks a lot shorter, doesn't it? Yeah, we were missing the KLs, and they were currently being added, so what did we do? We subtracted. This is the subtraction property of equality. Okay? The reason is this looks like this, right? And this looks like this. They haven't moved, right? But what's happened? KL went away. So we took away this distance between K and L from both sides. And all we're left with is the distance between JK equals to the distance between G and H. Okay? Next one. What says if this, then this? Distributive, the parentheses went away, right? And what happened? That 3 was multiplied by each. That's your distributive property. Okay. And what says if x equals y and y equals 2, then x has to equal 2. Reflexive, are we switching the signs of the equation? X equals y, so y equals x? Okay, but we'll have to substitute different numbers in there, right? So which pattern does this fit? This one is transitive, right? Because it says if x equals y, if a equals b, and y equals 2, b equals c, then a has to equal c. The y's went away, and we went strictly down to x equals 2. So this one's transitive. Yes. Some students will say substitution, and you can. Okay. I will take substitution in this case because we're substituting an equal value for both, but this is a classic textbook transitive. Okay. And oftentimes substitution can be subbed in for transitive, but not the other way around, because this one has a very definite pattern. Okay? All right. So far, so good? Okay. Mind blown yet? Assignment is your student journal. Let me find it for you.